In this topology, which switch will become root bridge? MAC address of switches are in front of you, and by
Which one?
default priority is configured.
Which
Switch
one?
one, sir.
Which one?
Which one?
So if switch 1 PC1 is pinging to PC2, which path will used? Let's say here IP address is IP is 10.1.1.1/24, and IP on PC2 is, let's say, 10.1.1.2. So first of all, traffic will reach on switch 3. Switch 3 will forward it to which switch? When I am pinging 10.2 from 10.1 means PC2 from PC1, how my traffic will flow? Let me show you topology as well. Yes. Tell me. Switch 3 will forward traffic to which switch? Frame to which switch? When I will ping PC2 from PC1. First of all, PC will forward traffic to switch 3. Switch 3 will forward to which switch? To root bridge?
Switch one.
Yes, to switch 1. Then switch 1 will forward it to which switch? Switch 2 or switch 4?
Which 4?
Definitely, very good.
Okay.
It will forward to switch 4 because this link will be also in forwarding state. And then switch 4 will forward it to switch 2. Now, what will be the priority over here on this switch? Tell me what will be the priority?
32768.
32768. Okay, let me show you the priority. How to check?
Show spanning tree.
Okay. So on switch number 1, I am going to run show a spanning tree. Priority is 32769.
9.
Now tell me guys, you were saying or we were discussing about the default priority, that is 32768. Then why it's showing 32768 plus 9?
One is for sir VLAN ID.
One is for VLAN ID.
System ID extension.
Okay, first of all, I want to verify that which type of spanning tree protocol I am running over here. Actually, we have multiple types of spanning tree protocol like CST, PVST, PVST plus RSTP, RPVST, MST. So how to verify which spanning tree protocols is running? For that, command is show spanning tree summary. This command will show you. Are you able to see which protocol I am running over here?
PVST.
PVST.
PVST. Okay. Okay, doesn't matter which protocols we are using. So a spanning tree. Here, first of all, you need to understand the concept of priority. Guys, priority is how long value it is. How long value it is priority?
16 bit.
16 bits.
Yeah, 65535 02 65535.
It is an 16.
No, sorry, 12 bits, sir. Sorry.
No, brother. It is 16 bits value.
16 bit,
You
yeah.
are right. So let's talk about the priority once again. Yesterday also, by the way, we had discussed. Same thing again I am going to make you understand today. See, priority is first of all root bridge ID. Root bridge ID is root bridge ID is how long value it is? 8 bytes value. It is an 8 bytes value. Out of 8 bytes, sorry guys, root bridge, it is an 8 bytes value. 8 bytes. Out of 8 bytes, as you know, root bridge is combination of two things. First one is priority, and second one is base MAC address. MAC address, and MAC address is 6 byte value. Yes or no? It is a 6 byte value. That means priority is 2 bytes value. Priority is 2 bytes value. Done. Again, we have divided this priority into two parts. Again, we have divided this priority priority into two parts. Priority is also a combination of two things. It is 2 bytes value. 2 bytes. And this 2 bytes is divided into two parts. This is your actual priority. This is your actual priority. And this one is your VLAN ID. VLAN ID. Done. ID. Priority is how many bits value? It is 4 bits value only. 4 bits value. And 12 bits is your VLAN ID. 12 bits is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? Combination of two things. And you know, by default priority value is this 1 0 0 0, and VLAN ID is same, like for VLAN 1 it will be 5 6 7 8 9 10 11 12. This, got it guys? This is your priority first 4 bits value, and this one is your VLAN ID.
Oh,
Last
byte means
bits, brother. Total size of priority is 2 bytes. Total size of your priority is 2 bytes.
but this value is 65536, no?
Which one? So see
Priority.
now why by default value is 32768. See now, wait now.
Okay.
Okay. What I am saying, that total size of priority is 2 byte. 2 byte. Out of the 2 byte, 4 bytes is reserved for priority and 12 bits is reserved for VLAN ID. 4 bits is reserved for priority and 12 bits is reserved for VLAN ID. So suppose for VLAN 1, this will be the VLAN ID, and by default priority is 1. This is your bits. First bits is reserved by default, right? And this value is actually 32768. If you are configuring priority what 0, that means priority over here will become what 0000. All field is 0, and VLAN ID 0000456789101. 1. So what priority will become 0 plus 1?
1.
It will be 1. By default this value is 1, right? So if you will calculate, this value is 32768. This value is 32768, and VLAN ID is, let's say, this one. Then 32768 plus 1,
9.
what will be the priority? 32769. Yes or no?
Yes.
Can we set priority 2? Can I configure priority 2 on switch? Let me try to configure priority 2. See, on switch number 1, just I am going to run one command, spanning tree
VLAN number.
VLAN numbers.
VLAN
spanning tree for VLAN 1 and priority
priority.
1. What it's saying? We can change the priority in the range of 4096. Yes or no? We can change the priority in the increment of 4096. See the reason why. Because this is my field for priority, and this one is VLAN ID, let's say. Okay. Here if you will set first bits 1 and 3 rest bit will be what? 0. So value will be what? Actually this is your 4096.
Required 13.
If you will calculate it, so this value will become what? 4096. So if one bits, first bits you will on in the priority, what value you will get? 4096. And VLAN ID is same, 00045678910111. 1. So if you will set this bits on, then priority for VLAN 1 will become what?
4097.
4097. For VLAN 2, priority will become what? 409.
4098.
Sorry, this is 7. 4098. For VLAN 3, value will be become what? Priority will become what? 4099. Okay. If you will set this bit also 1, then what value you will get?
8192 plus 409.
Yes. This value is actually
8192.
8192. So if I am setting these two bits 1, then what value I will get? What value you will get if you will add this value, guys? Okay, suppose let's say my priority is like this. I have set second bit as 1. Priority is, let's say, 2. So how you will write 2 in binary?
0010.
0010. Here value you will get 0, 0, 1, 0. This is 2. And decimal value of this will be what?
8192.
92. And suppose for VLAN 5, how you will write 5 in binary?
101.
It will be binary of 2. Yes or no? So here decimal value that I will get is 2, and here the decimal value that I am getting is 8192. So what will be the priority?
8192.
8194. Yes or no? Like this priority will work. So actually we have only 4 bits for priority. Done, guys? And this
Okay,
is the
sir.
reason why we are able to change the priority in the increment of 4096. Getting my point?
Yes, sir.
Okay. So that's why here you are able to see what priority. So spanning tree. Here you are able to see priority is 32769. Means priority is same default priority is 32768 plus VLAN ID. If I will configure priority 0, then what priority will be there?
1.
Spanning tree for VLAN 1. Priority is, let's say, 0. And so spanning tree. Priority is what? 1. Done, guys?
Yes, sir.
Yes,
Now
sir.
let me run no spanning tree for VLAN 1. Priority is 0. So spanning tree. Again, the default priority is there, right? So now my path is actually, my actual concern is this, not this. My actual concern is my path is this between source and destination. Yes or no? I want to use forward traffic like this. What I can do? I can make this switch as root bridge. Can I make this switch as root bridge? Yes. Okay. What will happen if I will configure this switch as root bridge? Now, if you want to verify the path, how you can verify? By checking the MAC address table. Yes or no? What is the MAC address of switch 1? Sorry, PC 1. So, IP. See, the MAC address of PC 1 is this one. Right? Let me write it over here. In the same way, let me show you the MAC address of PC2. So IP, and this one is MAC address of PC2. What is happening, guys?
Only the last one is 6, sir. Everything is same. You can just write.
Okay, this is MAC address of PC2. Now what you can do, you can check MAC address table of switch. So switch 1 will learn MAC address of PC1 on which interface? So MAC address table. Clear MAC address table dynamic, and so MAC address table dynamic. There is no any entry. Now I am going to ping again. Sorry. Ping 10.1.1.2. Ping 10.1.1.2. Ping is not working. So IP, what wrong? 10.1.1/24 is there, and so IP 10.1.2 is here. Why it's not pinging, guys? I have to verify the switch 3 configuration. On switch 3, the interface E1/0 is connected with PC1. So interface status E1/0. This port is down. Yes or no? So I need to run no set command over here. Interface E1/0, say no set. Let me write the configuration and do same thing. Let me check switch 4 configuration as well once. Enable so interface status. So E1/0 is down over here as well. Config T interface E1/0, say no set. And let me write the configuration. Done. Now I think ping will work. Ping this IP address. STP will take how much time? 30 seconds. So you will understand that also. Why a user need to wait for 30 seconds in case of PVST. After 30 seconds it will, ping will work. Okay, ping is working. Now let me show you the MAC address table of switch 1. So MAC address table dynamic. Clear MAC address table dynamic, and so MAC address table dynamic, there is no entry. See, PC1 MAC address is this one. On which interface? On E0/2. Switch have learned this MAC address on E0/2 interface. Where is E0/2? Is it possible, guys? Is it MAC address of PC1 or not? 5079666850. Yes. This MAC address should be on which interface? On 0/1. Sorry, 1/0. There is some issue with interface as well then. So MAC address table dynamic, and after that we can define the address as well, or let's say interface E1/0. On this interface there is no any MAC address. Oh, actually this one is switch 3, guys. Where are you?
Yes, sir.
I am
Switch one
checking
you
it
are.
on switch 1. So this one is switch 3. Okay. Here, so MAC address table dynamic, and clear MAC address table dynamic, and again I am going to check, again I am going to send ICMP traffic. Okay, so here you can see this MAC address of PC1 learned on which interface? On Ethernet 0/2, and MAC address of PC2 is learned on which interface? On Ethernet 0/0. Right? That means I am using this link between switch 1 and switch 3. Done. On switch number 1 now, I am going to check MAC address table dynamic, or by using interface also we can check, or by using MAC address also we can check. So MAC address dynamic. Well, this is MAC address of PC1, and this MAC address learned on which interface?
0/2.
2.
0/2, same on same interface. And MAC address of PC2,
One by
this
one.
one, is by 1 by 1, right? That means switch is using this link. Done?
Cross.
Yes or
Okay,
no?
sir. Yes.
That means now my path is this one,
Yeah.
right? Okay. I want to use this path. What I need to do? I need to make root switch to as a root bridge. Yes or no? But
Yes, sir.
before that, tell me what is logical topology. Switch 1, switch 2, switch 3, and switch 4. This is my root bridge. This is my root bridge. Which link I am using between switch 1 and switch 3?
0 by 2, 0, 0.
0 by 2. Which link I am using between switch 1 and switch 2?
0, 0, I guess. 0, 0.
0, 0. Very good. Which link I am using between switch 3 and switch 4? Or I am using link between switch 3 or 4 or not?
No. 1
No?
to, no, 1 to 4.
Okay. Between switch 2 and switch 4, am I using
No.
any link?
No, sir.
No? Okay. So I am using only this link. Means 1/1. Right, guys? According to you,
Yes.
this is your topology. Loop free
Yes, sir.
topology. Let me verify. On switch number 1, so spanning tree. Okay, all ports are designated port, no problem. On switch number 2, so spanning tree. 0/0 is RP. 0/0 is RP. 0/1 is alternate. 0/1 is alternate. Okay, let me take you on R4 directly. Let me check all ports of R4 is blocking or not. So spanning tree protocol. So few ports are DP, few ports are RP, and few ports are status. Sorry, root port RP. So interface status. By running this command, I cannot check. How I can check the STP states of port, guys? How I can check states of STP ports?
Show
So-
spanning tree.
So spanning tree,
Yes.
where is STP states?
Okay.
Here it is.
States STP.
Blocking, 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 forwarding, forwarding. So port number E0/2, E1/0 is also in forwarding state. E1/1 is also in forwarding state. Okay, then E1/0 is connected with which port? E1/0. E1/0.
Desktop PC है sir.
You see,
Okay, PC is there, right? So there is only one ports in forwarding state in STP domain. Okay, great. In the same way, on switch number 3 also we can run command show spanning tree protocol. And here also you can check state is forwarding, blocking, forwarding, 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 and blocking. So let me check forwarding port. E0/1. E0/1.
block.
E0/1 is blocking. Okay, forwarding is E0/2. E0/2 is connected with switch 4. But here this port is blocking. Yes or no? E0/2 on switch 4. Yeah, that means all are same because this is connected with PC and this one 0/3 is also in forwarding state and 0/3 is connected with same switch 4. And on switch 4 0/3 is alternate. So state is blocking. So this is your logical topology, right? Now I want to forward data via switch number 2. So what I can do, I have two options. Either I can configure higher priority on switch number 1. Automatically switch 2 will become what? Root breeze. Or I can configure the lower priority on switch number 2. So which option you want to use?
Lower priority.
Higher priority. So let me take you on switch number 1, and here I am going to say a spanning tree for which VLAN? For VLAN 1. After that, priority. See the priority range. By default priority is 32768. 32768. Guys, tell me what value I will get if you will add 4096 with this value. Three two seven six eight plus 4096. I will get this value 3636. Sorry.
रोंग डाल दीजिए ना सर, एक बारी अपना आप दिखा देगा वो.
Yeah, by the way, 36864. Done. हाँ, wrong भी डाल देंगे तो दिखा देगा. अगला, this one. I have set higher priority over here. Now let me check a spanning tree protocol. So a spanning tree. So you can see the root breeze ID is this one and breeze ID is this one. Both are different, yes or no? Breeze ID and root breeze ID is different. This is MAC address of switch 2. Yes or no? And on switch number 2, you can run command. So spanning tree. Here you can see breeze ID and root breeze ID both are same. And here is one keyword as well. This is the root. Done. And all ports of root breeze is designated. So now if I will ping PC2 from PC number 1, which path will used?
Switch 3 to switch 2 to switch 4.
Switch 3 to switch 2, then to 4. Now tell me which link between switch 2 and switch 4?
0
Which
2.
link? 0 2.
2 of switch 2.
I want to use now this link. Now I want to use this link. So what I can do?
You can reduce your path cost.
Yes. Here path cost is
100.
19.
100. Sir.
100. Yes,
100.
it's Ethernet link. 100. Here also path cost is 100. Guys, path cost is also, just understand path cost first. What is the size of path cost? What is the size of path cost? It is an 8 bits value. Understand STP port ID first. Port ID is 8 bits value. Port ID is combination of two things. First one is
Port priority.
Port priority and then
Interface
port
number.
ID. Port priority is 4 bits value and this one is also 4 bits value, right? And this value STP port priority will also incremented by in the range of 16 only, because the value is 4 bytes. If you will configure one if you will set this bit 1, what decimal value you will get? 1? Not 1. You will get 16. Yes or no? Because last 4 bits is 0000. This is port ID. So this value is actually 16. This one is 32. This one is 64. And this one is 128. And by default, this bit is 1.
Sir,
So
4 bit we can write 80 also, no, sir?
80?
8 times 0, 4 bit, because 1 bit is 0 1, na?
Now by default it is 1000. So this is the reason by default port priority is what? 128.
128.
Yes or no? This is
Okay.
STP port ID. But here we are not going to discuss about this port ID. Here we are going to discuss route path cost. RPC means path to reach route bridge. So here path to reach route bridge is 10, 100, and here also path to reach route bridge is 200. Now
Sir,
tell me why this port is your RP and why this one is alternate. On the
sir,
basis of, yes,
why ये जो पोर्ट आईडी है वो
okay,
आपने बताया था 4 बिट की है, वो भी
4 bits नहीं 8 bits.
8 बिट्स।
Yes,
तो वो
जिसमें
क्या
से 4 प्रायोरिटी है
256
4 बिट्स, जिसमें से मैंने बताया एसटीपी पोर्ट आईडी इज 8 बिट्स इंफॉर्मेशन, 4 बिट्स इज for priority and 4 bits is for interface ID. And by default, this bit is default. This bit is fixed. That is 1. So that's why your value, your STP port is, your STP priority is 128. So suppose my interface is 0/0. So here value will be what? 0. So what STP port ID you will get 128.0. Right? If here I will set it 0 and here I will set all 0, then priority will become what? 0. Then STP port ID will become what? 0.0. If here I will set value 1, here I will set value 1, then what value you will get? 16 over here. So port ID will be 16.0, like this. Is it clear, Vicky?
यस सर। नहीं, मैं ये पूछ रहा था इंटरफेस 128 तक ये ले सकता है क्या? 128.128।
How many value you can write by using 4 bits?
128 है ना?
So
256
120.
all one तो 256।
So 256 होगा ना भाई, all 1 हो सकते हैं ना. Value can be 0001, value can be 0000 till 1111. Yes or no?
Okay.
So these can be your interface ID. Done? Is it clear, Vicky, or still do you have confusion?
मैं ये पूछ रहा था सर, इसमें स्विच के 128 पोर्ट मिल सकते हैं हमें?
मिल सकते हैं ना, मिलते हैं ना, क्यों नहीं मिलेंगे?
Okay.
Done. Now I need to change port priority. Yes or no? RPC, route path cost. On which switch you will change? On switch number 4. See, first of all, why this port is your RP and this one is alternate. On the basis of what? Switch 4 is electing RP. First of all, it will check route bridge ID. So route bridge ID will be same on both link. Then it will check what? Route path cost.
interface.
So that will be also same. Then it will check what? Sender bridge ID. That will be also same. Then it will check what? Sender port ID. And on the basis of sender port ID, now election is happening. But if I will change the RPC over here, then election will happen on the basis of RPC. Yes or no? Route path cost. So let me take you on switch number 4. And again I have two options. Either I can increase or I can decrease interface interface, let's say E 0/1. A spanning tree for VLAN 1. After that, cost. So what cost you want to set it over here? What is this, guys? Port cost, port priority. This is the value you need to change, or the cost you need to change. What value you need to change it over here? Tell me. You
We
need to
can change
change
port
Port
priority also.
priority और cost.
cost or port priority.
So कुछ भी cost भी कर सकते हैं. Port
Cost B.
मतलब cost is
Port
equal
priority,
right now,
sir.
right? So if we change the port priority also, it will change the.
If I will set cost 10 over here, then what will happen? Will anything happen?
Yes, sir.
So spanning tree. Which port is RP? Which port is RP, guys?
0/1.
This one.
0/1.
Because here cost is 10.
10.
Here cost is 100. Now I am going to remove this configuration. Interface E 0/1 and say no. And a spanning tree for VLAN 1 port priority. क्या सेट कर दूं? 10 तो सेट होगा नहीं, right? So we can set 16 over here. Now what will happen? Will anything happen? So a spanning tree. Now RP is 0/0. RP is 0/0. Actually, you have changed this cost, this port priority. Actually, when it will check the receiving interface ID, that time it will, perform election on the basis of this port priority. Yes or no?
सर अभी आपने क्या
नहीं समझ में आया.
इंटरफेस
मतलब
मोड
why
पे
is it changing on 0/1?
Yes. First of all, switch will check what? Root bridge ID. Then switch will check what? Cost. Cost is same. Yes or no? Then switch will check what?
Priority.
Sender bridge ID. So sender bridge ID is also same. Then switch is going to check what? Sender.
Receiver bridge ID.
Yeah. No. Sender port ID.
Okay.
So sender port ID of 0/2 is lower. So that is best. If sender port ID is also same, then it is going to check this one.
Okay.
Right? This is the receiver port ID. And this is the cost. This is not the port priority. This is cost. This is RPC. Distance to reach root bridge. Distance to reach root bridge. Done, guys?
सर
So
बार
there is
दोनों
no
कमांड
any
दिखाना है.
logic. There is no any logic of changing port priority over here. Interface E 0/1 and say no. Port priority हम किस सिनेरियो में चेंज करते हैं? See, suppose.
सर अगर
Let
switch
me
2 में
let me
सॉरी
yeah.
सर अगर switch 2 में port priority change करेंगे
Okay.
तो
Switch 2 में port priority change करेंगे. Sender port ID. Yeah, so वही तो मैं बोला कि again we have two option. Again I have two option. Either I can modify the configuration on switch number 2 or I can modify the configuration on switch number 4.
Okay.
Right. अगर मैं यहाँ पे एक टोपोलॉजी और बनाऊं, let me do one thing. Not here, it is possible. I can design it on real devices. let me do one thing. Let me turn on my class. Now here in this topology, switch 4 is receiving BPDU on both port on 0 slash, switch 4 is receiving BPDU on both port 0 slash 0 and 0 slash 1. It is performing, it is receiving superior BPDU on which port?
0 by 0.
On 0 by 0. On
Yes.
the basis of what?
Port ID.
Under port ID.
On the basis of sender port ID.
Yes.
So if I will take you on switch number 1, so spanning tree, yes, 0 slash 0 is my root port. So if I will take you on switch number 2, and if I will increase the, if I will decrease the, sorry, if I will decrease the port priority of E0 slash 3, then what will happen?
That should
Interface
It will forward, sir.
0 slash 3. Here I am going to say a spanning tree for which VLAN? For VLAN 1 and port priority, let's say 16. So a spanning tree. So here you can see port priority is lower than this one. Right. Now on switch number 4. So a spanning tree. See which port is root port? 0 slash 1. Done, guys. And switch is checking receiving port ID as well. Switch will check receiving port ID as well. Cost is different. Suppose here I have a topology like this. Switch 1, switch 2, and switch 3. Here I have one link. Here I have two link. Let's say here I will disable what? STP. No STP is running here. This is my switch 1. This one is switch 2. This one is 0 slash 0. And this one is 0 slash 0. This one is 0 slash 1. In this scenario, which port will become RP on switch 2? 0B. Which port will become RP on switch 2?
0 by
Tell
0,
me, guys.
sir. 0 by 0.
0 by 0. Why? On the basis of
receiving port ID.
Receiving port ID.
Yes.
If you want to verify, I can show you. Here what I am going to do. Actually, when we are disabling the spanning tree protocol on simulation software, I think there is some problem. That's why I am going to take access of my real device. PM networking 1 2 3. Let's say switch 1. PM 1 2 3.
अगर सर स्पैनिंग ट्री को डिसेबल कर देंगे,
ओके,
तो क्या वो बीपीडीयू भेजेगा?
नो.
तो वो अब स्विच 2 क्यों भेज रहा है सर उसको बीपीडीयू?
कहाँ पे स्पैनिंग ट्री बंद किया है अभी मैंने?
नो स्पैनिंग ट्री किया है ना स्विच 2 में?
नहीं,
अभी
पे नहीं किया।
अभी टोपोलॉजी में सर
यहाँ पे
हाँ जी आपने
ये रिले तो करेगा. इट विल रिले द बीपीडीयू. इट विल रिले द बीपीडीयू.
ओके।
Switch 2 is not generating BPDU. It is just relaying the BPDU of switch 1
वो
to
तो वैसे भी
switch 2.
नहीं जनरेट करेगा सर, वो तो स्विच टू
Yes,
भी नहीं जनरेट कर पाएगा ऐसे तो।
switch 2 will generate BPDU. It will forward
नो
it to
टीसीएन बीपीडीयू करेगा ना सिर्फ ये तो,
why?
स्विच टू। नॉन रूट ब्रिज
Why?
है सर, टीसीएन बीपीडीयू जनरेट करता है वो तो।
Why it will generate TCN BPDU when
नहीं
change will
टोपोलॉजी
occur
चेंज,
then?
नहीं हाँ, जब कोई चेंज होगा, वैसे तो बाय डिफॉल्ट तो रूट ब्रिज ही जनरेट करेगा बीपीडीयू।
Brother, what I am saying that suppose this is your hub.
यस।
This is your hub. This is not your switch. So my concern is when switch 1 will send a BPDU to switch 2, in both sender port ID will be same. Then switch 2 will elect the superior BPDU on the basis of what? On the basis of receiving port ID.
वो ये तो समझ गया सर मैं। भाई ये वैसे तो स्विच टू भी जो है अभी, ये आपने स्विच टू
TCN
बता रखा।
BPDU का यहाँ पे कोई रोल ही नहीं है ना।
हाँ नहीं है, वो तो टोपोलॉजी चेंज होगा तभी होगा। वैसे बाय डिफॉल्ट तो स्विच नॉन रूट ब्रिज तो कॉन्फ़िगरेशन बीपीडीयू जनरेट ही नहीं करता ना।
ये भी नहीं जनरेट करेगा।
नहीं अभी आप बोल रहे थे ना स्विच टू तो जनरेट कर पाएगा, लेकिन ये तो नहीं कर पाएगा नॉन
फर्स्ट टाइम
एसटीपी
दोनों
वाला।
स्विच जनरेट करेगा कॉन्फ़िगरेशन
हाँ
बीपीडीयू
वो तो
अपना अपना। जब इसको
वो
पता
तो
चल
तब
जाएगा
तो
कि
अपना खुद को समझेगा रूट ब्रिज है, तभी
हाँ,
करेगा।
after that what I am saying that switch 2 will send BPDU.
हाँ अभी आप बोल रहे थे ना स्विच टू जनरेट करेगा बीपीडीयू।
Don't think so. I don't think so, brother.
ओके सर।
Okay. So PM 1 2 3 switch 3. Here I have switch 1, here I have switch 2, and here I have switch 3. Let me close the rest. So CDP neighbor, so CDP neighbor switch 3, switch 3 is neighbor on 0/23, and so CDP neighbor switch 2 is neighbor. So interface status 0/23 22 not connected. Okay, on switch number 1, so interface status 0/19 and 20 is disabled. Okay, so I am going to run no set command on interface range f1/0/19 to 20, say no set, and so CDP neighbor switch 2 is neighbor on 0/19, so interface status not connected. So CDP neighbor switch 1 and switch 2. Okay, link between switch 2 and switch 3 is not working. Just give me 1 minute, let me check. I think there is some issue with cable. Okay, so CDP neighbor, here you can see there is only one link between switch 1 and switch 2, but between switch 2 and switch 3 there are two links. So CDP neighbor done. Now on switch number 2 I am going to disable a spanning tree protocol. Say no spanning tree for VLAN 1. So spanning tree, right? Spanning tree is not running here. No spanning tree instance exists. Okay. Now on switch number 3, so spanning tree. So this is root bridge on switch number 1. So spanning tree. I am going to make switch 1 as a root bridge. So what command I will run? A spanning tree for VLAN 1, and let's say priority is 0 over here. So this switch will become root bridge. So a spanning tree. This is root bridge switch. Now tell me on switch number 2 which port will become RP? 0/19 or 0/11?
0/11.
0/11, because it is checking what? Receiving port ID as well. Here on switch
Yes,
number
sir.
3 you can see 0/11 is designated port. 0/11 is RP,
It's
root
okay.
port, right? And see how it is using what? STP port ID. STP port ID is 128.13. Here it is 25. So it is adding value what? 2. So we'll discuss about that 2 value as well. This is, on switch number 1, if you will check, here you can see port ID is 21. So all switches are adding value 2. Don't worry about this. But now if here I will reduce the priority of port of 0/23, then this port will become what? RP. Because this time election best BPDU election is happening on the basis of receiving port ID. Yes or no? So here you will not change the cost value, brother. Here you will not change cost value because election is happening on the basis of cost is 19 from both sides. If you will change cost on which port? On let's say 0/23. I want to make this port as a best interface F 0/11 as a best. Spanning tree
VLAN 1.
VLAN 1.
VLAN
But
1
0/11 is already enough, sir.
and port priority. I am going to set higher port priority over here.
Okay.
Yes or no?
Yes, sir.
16, 32. I can set 32. 32. So spanning tree. Oh,
नहीं 129 होगा सर 129.
129.
What, sir? क्या 129 होगा? वो 16 को ऐड करेगा ना सर? 144 होगा वो.
Yes, so here you should
144
configure port priority greater than 128, and that should
144
be
होगा.
divisible via 16. So it will be 144. 128 plus
16.
16. Yes or no? And now if you will check, so a spanning tree, you can see. Done.
सर फिर भी वो रूट है.
फिर भी वो रूट है. That
थोड़ा
means
टाइम लगेगा ना सर वो उसमें.
30 सेकंड लगेगा क्या?
no.
ये क्या हो गया?
ये क्या हो गया? Cost from both sides is same. Everything is same.
Sir, in switch 2 we have to change the priority value.
Yes.
In switch 2 we have to change the priority value 11. Okay. Oh, there is no spanning tree, right?
No, no, no. Switch to, I have disabled spanning
Yes,
tree
yes,
there.
yes, yes.
पोर्ट शट डाउन नॉट शट डाउन करके देखना सर भाई.
Interface range F0/11 and F0/19. 19 or 23.
23.
Say shutdown and say no shutdown. So a spanning tree.
अब चेंज हुआ.
ये क्या आपके रियल डिवाइस है क्या सर ये?
Yes, yes, yes.
Root just moved from listening to learning. Still coming up.
Yeah, this is in forwarding state now. But election happened, na? This one is my root port. That's why it is in learning state. You can see
Yes,
it have this port is stuck in blocking state. I think we need to wait for 20 seconds because max's time is 20 seconds. After 20 seconds, it is going to change the role. Because still superior BPDU was there for 20 seconds. After 20 seconds, it will flush that.
फॉरवर्ड डिले टाइम इसको ये उसका एजिंग टाइम है.
Forward delay is like forward delay
15 सेकंड कर देता है
time.
उसको मैक एजिंग टाइम को.
No, those concepts of are change, topology change. That was our topic, but we are on different track. No worry. Max's time is like hold on time. So whenever switch will receive a BPDU on an interface, switch will hold that BPDU on that interface for 20 seconds. So superior BPDU was there for 20 seconds. So maybe that can be the also reason. And sometime because we are not running STP on switch number 2, that's why also error can be there. But when I have shut down the port and I have not shut down the port, after that you can see the result. But these are real devices. Here we cannot say this is a software problem or this thing.
Yes, sir.
Only things that here we have disabled a spanning tree protocol on switch number 2. That's it. So see Vicky, still I am not running STP on switch number 2, but switch 2 is relaying the BPDU. Yes or no?
Yes, sir. It's not generating, but
yes, it will not generate only. Yeah. Done.
Yes, sir.
So actually just I was trying to make you understand that switch is using their on port receiving port ID as well for the root port election, for the STP election. Done. Now in my scenario, now my topology is which port? Which port switches are using between switch 2 and switch 4? 0/0 or 0/3?
0 by 0.
0 by 0 is not there. 0 by 2 or 0 by 3.
0/2 और
0/3 में शिफ्ट किए थे।
0/3.
0/3 में शिफ्ट कर दिए थे ना.
ओके.
Yes. So this is my best path, right? Now this is my root bridge switch. My logical topology is this.
Yes.
My logical topology is this. So here is my PC. I want to make logical topology like this. Switch 1, switch 2, switch 3 and switch 4. Like this. What can you do, brother? Tell me. I want to design my topology like this or like this. Yes. Or like this. Or like this. Yes. Tell me. What can I do? See, this is my root bridge. All ports of root bridge switches what? DP? All ports of root bridge switches DP na? Yes.
Yes, sir.
These all ports are DP. Here which port is RP? On switch number 1, which port is RP?
E0/0.
This port is RP, right? And between switch 1 and switch 3, switches are not using any link, yes or no? But you want to use link between switch 2, 1 and switch 3 also. You don't want to use this link. So guys, tell me what you will do.
1/1 का cost बढ़ा दें.
See, first of all, switch number 3 is receiving BPD over here also. It is receiving BPD over here also, right? Root bridge ID in the both BPDU is same. Then it is going to check
Yes, sir.
cost, and on the basis of cost, this port is becoming what? RP. So if I will increase the cost over here, then this port will not become RP, yes or no?
Yes, sir.
So how much cost I need to increase over here? Here by default cost is
38. 19%.
200, sir.
200.
Yes, sir.
Here
100.
also 200. Here 100. So here if I will set 201.
Yes.
Here if I will set cost 201. Then out of these two port, one port will become what? RP on this switch. So then which port will become RP?
0/0.
This port 00. This port will become what? RP. So my topology will be this one and this one. Yes or no? And this one. हो गया? Yes or no?
Yes, sir.
So let me do this. On switch number 3, config T, interface E1/1, a spanning tree for VLAN 1 and cost 201, and so a spanning tree. Now tell me which port is root port? Still this port is root port. Wait.
Now it's okay, sir.
Now it's okay.
Yes. One
Now
by
my topology is, logical topology is switch 1 connected with switch 3 and switch 2. Switch 2 is connected through switch 4 and switch 1. Yes or no?
Yes, sir.
My logical topology is now different. So a spanning tree. Here you can see the RP. RP port is the port to reach root bridge. So which port is RP?
02 connecting to
2 by 2.
4.
0 by 2. And 0 by 2 is connected with one switch. Which switch? Switch 1.
No, सर ये
Yes, yes.
अच्छा स्विच 1 है क्या?
Switch 3 का सर.
तो ये स्विच 3 है कि स्विच 1 है?
Switch
Switch
3
3.
है ना ये.
स्विच 3 तो 0 कनेक्टिंग हो रहा है ना स्विच 1
0
को.
by 3 होगा सर switch 1 से.
This one is 0 by 3.
नहीं
0 by 2 का तो ये दिखा रहा है ना
connecting
सर.
to switch 4.
No, no.
Switch 4 वाला दिखा रहा है ये 0 by 2 का.
Okay, okay. I am talking. I am,
Switch 4 से
using
connect है.
wrong port, na? Yes, yes, yes. Sorry. This is my RP. Okay, I am right, na, brother. On
Sir.
0/ on switch number 3, 0/2 is your RP.
That is connecting to switch 4 sir.
Switch
Sir.
1.
नहीं अब ये 0 by 0 और 0 by 1 तो
Okay.
दोनों ही ब्लॉक
Now
दिखा रहे हैं सर.
this time root port is this port, right? Not this port. So still there is problem.
Yes. ये तो दोनों ब्लॉक दिखा रहा है switch 1 वाले.
I think it is because switch 2 is bridge now.
Yeah, switch 2 is root bridge. So switch 2 is advertising BPD over here also, and over here also, right? First of all, it is going to check root bridge ID. So root bridge ID is same in all. Then it is going to check what? Cost. So cost over here was list, but I have increased the cost over here. Now cost over here is 201.
नहीं सर वो सेंडर ब्रिज आईडी स्विच 1 का प्रायोरिटी हम लोग हाई कर दिए थे ना, इसीलिए इट इज कनेक्टिंग टू स्विच E0/2.
No, sender bridge ID of switch 1 is
Higher now.
lower than switch 4.
No sir, we increase the priority. It is not 32768 anymore.
Over here, okay.
Ah.
Yes. Exactly. Thank you. So what I am going to do? Okay, let's design topology like this. Switch 1, switch 4, switch 3, like this. It is possible, na?
Yes.
Yes. So yes, this port is connected with
Switch 4.
this port means this is my switch 3, and switch 3 0/2 is connected with switch 4 0/2. Now let me take you on switch number 4. And here show a spanning tree. Which port is RP? 0/1. And 0/1 is connected with which port? Which switch?
2.
2. Right? And here is switch 1, and definitely switch 1 is connected with switch 4. So this is my logical topology now.
Sir, to get your first logical topology,
Yes.
switch 1, switch 3, switch 4 will need to have
Here
same
also
priority.
we can. Okay.
Switch 2 का प्रायोरिटी डिक्रीज करेंगे तो भी
Switch 4 का
होगा ना.
switch 4 का ही डिक्रीज कर दीजिए ना.
हाँ मतलब कोई नहीं, स्विच 2 का करेंगे तो स्विच 2 रूट रहेगा ना.
Yeah, exactly.
हाँ, so that way also we can do, right?
That also will work. That will also work. Done, guys. So till here everything is okay or not?
Yes.
Now
Yes, sir.
this switch number 3, now my logical topology is this one. Yes or no? So if I will ping from here to here, my communication will be like this. Done? Now tell me what will happen if this port will goes down. What STP will do? STP will think that change occur. Change occur in spanning tree. But this PC is not in STP domain. This is my STP domain. Yes or no? PC is out of STP domain. So that's why this type of change is called insignificant change. Insignificant change. And now question is, what will happen when this port will goes down? This switch will think that change occur in STP. So this switch will generate a TCN BPDU. Guys, as I had discussed that there are two types of BPDU. First one is configuration BPDU and second one is TCN BPDU. We had discussed there are lots of content in configuration BPDU, but in TCN BPDU there are very less information. One will be the protocol ID. Protocol ID will be there. After that version will be there and type field will be there only. Type field. Through type field only we can identify now that it is an TCN BPDU or configuration BPDU. So there will be type field information. Only these information will be there inside the TCN BPDU. Getting my point?
Yes, sir.
Inside the TCN BPDU. And whenever change will occur, what switch will do? Switch will generate a TCN BPDU to inform the root bridge that hey root bridge, someone have gone from my port or whatever change has occurred. Just this switch want to inform root bridge, not the reason, not how change will occur and what change occur. Just it is going to inform to root bridge switch that change is occur in the topology. Through which BPDU? Through TCN BPDU. Guys, in the BPDU we had discussed there was one field called flag field. Yes or no? Flag. There are 8 bits. Flag is 8 bits value. First one, it will start from 0, 1, 2, 3, 4, 5, 6, 7. These are the flags in the BPDU. Done. And 7th bit is your TC ACK bit. This is TC ACK bit. And this one, first bit is your TC bit. Topology change bit in the flag, and these all are unused. Unused flag. So there are only 2 used flag. One is 0 and second one is 7. 7 is TC ACK and 01 is TC. Done. If it is clear to you, make you understand topology change is very easy for me. Is it clear? There are 8 flag
Yes.
in the BPDU. 0 to 7. 0 is TC and 0 is TC ACK and 7 is TC. All other are unused. We will use these flag later. For now, just understand that these are unused flag. Okay. So whenever change will occur, what this switch will do? This switch will generate a TCN BPDU, and TCN BPDU will be forwarded by a switch from RP, from the root port. So which port is root port? Which port is RP on switch 3? This one.
2.
0 by 2.
Yes.
So it is going to send TCN BPDU from here. Now 2 things will happen. Root bridge have knowledge about the topology change. Yes or no? So first of all, root bridge have to send acknowledgement, because if root bridge will not send acknowledgement, this switch will continue sending the TCN BPDU. Actually, non-root bridge switch will send TCN BPDU until and unless it will not receive acknowledgement from the root bridge switch. Done. Otherwise, after every 2 seconds, it will send one TCN BPDU to root bridge. So, next step is when root bridge switch will receive the TCN BPDU, it is root bridge cannot generate TCN BPDU. Root bridge generate what? Configuration BPDU. In the configuration BPDU, root bridge will on both bit. One is TC bit, TCN bit, and another one is TC bit and TC ACK bit. TC ACK bit is for switch number 3. When switch 3 will receive this configuration BPDU, it will check the acknowledgement field. If acknowledgement value is 1, it will stop sending what? TC and BPDU. And this bit is for all other switches in the STP domain. Switch 1 will also came to know that there is some change in the topology. Switch 4 will also came to know that there is some change in the topology, because now root bridge is sending configuration BPDU with TC bit on. Okay, in normal BPDU both bit will be what? Off. Both bit will be off in the normal configuration BPDU. But whenever root bridge will receive a TC and BPDU, it will on TC ACK and TC bit in the first BPDU. After that, in the second BPDU, it will remove acknowledgement as well, and it will send TC bit on BPDU until forward delay time and forward delay time and plus maxes time. Maxes time. May I know the forward delay time, guys?
15 seconds.
Forward
15
delay
seconds,
time.
sir.
15 seconds.
And maxes time?
20.
20 seconds.
20 seconds. That means for 35 seconds, root bridge switch will send what? TC bit on configuration BPDU. Done. For 35 seconds, switch 2 will send TC bit on BPDU. And when root bridge switch send TC bit on BPDU, all switches will set their MAC aging time to 15 seconds. So MAC aging time, by default MAC aging time is what? 300 seconds.
300
Yes or
seconds.
no? So all switches are going to set their MAC aging time what? 300 seconds. Now understand the reason why. Suppose MAC address of this machine is A. So switch number 3 have learned A MAC address on which port? A MAC address on 0/1, sorry, on 1/0 port. Yes or no?
Yes.
And MAC address of PC2 is, let's say, B. So MAC address of PC2, this switch will run on which port? 0/2 port. This is RP. Yes or no?
Yes.
Now suppose someone have disconnect this computer from here and someone have put this computer over here. There is no any topology change notification in a spanning tree protocol, right? There is no any topology change notification in the spanning tree domain. So in the switch 4 MAC address table, there will be also some entry. Yes or no? Suppose here, let me talk about switch 1 and MAC address table. Switch will learn A MAC address on which port, guys? On, I think, 0/0 port. A MAC on 0/0. And which MAC? B MAC also on 0/0 port. Yes or no? Both MAC address switch 1 will learn on this port. Both MAC address. Suppose here is one some PC, and if this PC want to communicate with these guys, so this switch will learn both MAC address on this port because this is RP. Yes or no?
Yes.
Now someone have removed this computer from here and someone have connect the computer over here, right? But if this PC will generate a traffic for this user, this user will send it to switch 3. Switch 3 will check their MAC address table. In their MAC address table, this entry will be for 300 seconds. Yes or no?
Yes.
It will forward it from this port. Switch 2 will check it. Switch 4 will check it, and it will forward it from E 0/2 because there will be also one entry. If this PC is directly not connected with this switch, with switch 4, suppose there is one more switch between this PC and this switch. Then it will learn MAC address of PC2 on this port. So it will maintain that MAC address table for 300 seconds. Not like that. Okay. Let's assume on route switch number 2. It have forward the traffic on switch number 4. And let's say switch 4 don't have what? MAC address table in the MAC address table. Or let's say switch have MAC address table towards this interface. So it will forward traffic toward this interface. But now this destination is available over here via through route switch number 2. Yes or no? So for 300 seconds there will be wrong entry in the MAC address table of many switches in the topology. Here we have only 4 switches. In the real time, suppose there are 20 switches. So lots of switches will have the wrong entry in their MAC address table for 300 seconds. So that's why whenever change will occur, first thing that switch will do is, first of all, switches is going to reduce the MAC aging time. Done. Hope it is clear to you. Hope it is clear the what is the benefit of changing the MAC aging time. Yes or no? If anyone have a still problem, guys, tell me. I can design one another topology. What is the benefit of changing MAC aging time in case of topology change?
Actually, it is used to stop the broadcast tone.
Yes, exactly. It is used to reduce a non-unicast flooding, actually. A non-unicast flooding. If there is wrong entry na guys, communication will never happen. Suppose now I have connected one switch over here. Not like this. Let's say there is one switch between switch 4 and switch 5. There is one switch. So switch 4 have learned B MAC address on which port? Let's say this is switch 5. B MAC address on E 1/0. A MAC address on 2/0. Here A MAC address 1/0 and B MAC address 0/2. Yes or no? Now suppose this PC goes down. This PC is now not available over here. This PC is now available over here. So tell me, will this switch remove this entry soon, or it will remove this entry after 300 seconds? It will remove entry after 300 seconds definitely. So whenever switch 4 will receive any frame from any switches where destination is B, it will forward that frame from here. Yes or no? And this switch will perform what? A non-unicast flooding, because this switch don't have the entry in their MAC address table. Getting my point? So whenever change will occur, first thing, switches need to reduce the MAC aging time. Right? First of all, we need to flush the MAC address table. Again, switches can build the MAC address table. Now question is, tell me, what about the static entry? There are some static entry in the MAC address table. Will switch will flush those entry as well?
सर
Yes.
अगर स्विच 3 में अगर ये TCN BPD जनरेट कर रहा है, टोपोलॉजी चेंज हो गया, अगर हमने इसका मैक एड्रेस अगर स्टैटिक डाल रखा है तो क्या होगा सर? और स्विच PC2 स्विच 1 पे जाके कनेक्ट हो गया,
आपने इसका एंट्री यहाँ पे स्टैटिक दे के रखा है?
हाँ,
किसका? PC2 का और
मैक
PCA
एजिंग
का?
टाइम इसका
मैक
PC
एजिंग टाइम आपने 0 कर दिया। स्टैटिक करने का मतलब होता है कि 0 कर देना।
अच्छा, तो
मैक एजिंग टाइम अगर किसी भी का आप 0 कर देते हो ना, तो वो एंट्री परमानेंट हो जाती है।
ओके, फिर क्या होगा सर उस कंडीशन में?
उस कंडीशन में वो मैक एड्रेस फ्लश नहीं होगी।
तो
मैक एजिंग टाइम 15 सेकेंड का मतलब क्या हुआ कि जितने भी मैक एड्रेस तूने लर्न किया है ना उसको 15
वो
सेकंड
रिमूव
के
कर
बाद
दो,
क्या कर दे, रिमूव कर दे।
फ्लश कर दो। हाँ
जो डायनामिक लर्न किया है ना कि स्टैटिक लर्न किया है।
ओके। तो अब
डन।
जो स्टैटिक का रखा है तो उसका क्या रहेगा सर?
वो वैसे का वैसे ही रहेगा, एंट्री उसमें पड़ा
तो वो
रहेगा।
उसके लिए अननोन यूनिकास्ट फ्लडिंग करता रहेगा।
उसके लिए नॉन यूनिकास्ट फ्लडिंग करता रहेगा।
ओके।
तो
तो
ऐसे
ये
गलती आप करोगे क्यों? क्यों कि कोई स्टैटिक एंट्री बना के और पीसी
नहीं,
को ही
आपने
हटा दोगे।
आपने बताया था ना पहले, लूप को अवॉइड करने के लिए करते हैं।
यस, तो अगर आप वैसे करते हो तो उस पीसी को नहीं हटाओगे ना। अगर मैंने स्टैटिक एंट्री लगाया है इस पीसी के लिए
हाँ।
यहाँ पे, तो इस पीसी को मैं कभी यहाँ से रिमूव ही नहीं करूंगा। जब पीसी को मैं यहाँ से रिमूव करूंगा दैट टाइम आई विल रिमूव दैट मैक एड्रेस ऑल्सो फ्रॉम द मैक एड्रेस
नहीं,
टेबल।
यूजर यूजर भी तो कर देते हैं ना सर, आपस में।
क्या?
पीसी किसी ने उठा के एक्सचेंज कर लिया पीसी।
हाँ, तो उस सिनेरियो में हम नहीं करते ना स्टैटिक एंट्री।
ओके।
Static entry is for permanent devices. Like suppose in the server room there are some servers, right? I don't want that switch will flood. For switch performs a non-unicast flooding for this server. So I will configure a static entry over here,
ओके
right?
सर।
And here you are not allowed to switch the server. Okay, brother. और डेफिनेटली अगर ऐसा करेंगे तो फिर प्रॉब्लम होगा, फिर नेटवर्क इंजीनियर आएगा, टिकट असाइन होगा, राइट। डन। एनीथिंग
यस
एल्स?
सर।